Hi, so in this video we're going to be modeling a revenue problem which occurs often in quadratics, and you often have to use the completing square method to find the solution that we're looking for. So this is modeling a revenue problem with a quadratic. So we are going to sell sandwiches and let's say we sell them for $10 per sandwich. Last year we sold 400 sandwiches, and we want to change the price. We kind of want to maximize our revenue. So if we increase the cost by $1, we sell 20 less sandwiches. So what we want to do is find a way to maximize our revenue. So in this case, we'd make an equation. We just say, well, the revenue, R, is equal to the cost times how many we sell. So we'll say number sold. Now, if we wanted to make a cost function, I would say the cost is going to equal $10 plus $1 times n amount of times. We might do it twice. If we increase it twice, then that's $12. So n is how many times we increase it by $1. And the number sold is equal to 400, but we're going to lose 20 sandwiches that we sell for every time we increase the price by $1. So now we have separate functions for how many times we change the cost. So now our revenue is the cost, which is 10 plus 1n times 400 minus 20n. So what we do here is we FOIL this out, and what we get is the revenue is 4,000 minus 200n plus 400n minus 20n squared. We're going to rearrange this and group it. And then we have minus 20n squared plus 200n plus 4,000. So here we've got a function for our revenue, but we want to now find the vertex. So we can find the vertex by completing the square. So we'll group the first two terms, and we have to factor out the negative 20, and that gives us minus 10. Now we want to take half of this and square it. So that's plus 5 squared, and then because we added it, we have to subtract it, plus 4,000. Now, I'm going to move this up. Move it right here for now. So what we have, actually I can shimmy that back down so you can see a little bit more. So what we have is this, and I'm going to bring this term outside of the bracket. And when I do that, I have to multiply by 20. negative 20, I should say. And I'm going to leave this as 5 squared, and it'll make sense in a second. When I bring this one out, that's 25, but it's a negative. So negative 25 times negative 20 is positive 500. Okay, so now we'll pull this down. Now the revenue is negative 20 bracket, and now we can actually factor this. And because it's a perfect square, it's really easy to factor. So the perfect square is going to be, we'll take the first term, or the first variable, in this case is an n, and we take the sign in front of that, just the first power n, so the negative, and then we take the number here, which is 5, and we square that. So we just take the variable, the first sign, and the last number. And now we group these two, which is 4,500. And now what we've actually done is we've completed the square, and we've found the vertex. So we know the vertex is at 5, 4,500. So if we want to graph this, our revenue is here, and n is here. Now we know the vertex happens around 5, not around 5, at 5 I should say, and it's at 4,500. And it opens downwards because a is negative. When n is 0, what do you think happens with n is 0? We can actually just go to our rearranged form. Let me pull this down a bit more. When n is 0, we see that r is 4,000 because it's in standard form. We can just read that. So here is 4,000. So this is another point. And now if we increased n a huge amount, eventually it would actually just go back to 0 because no one would buy our sandwiches because we'd be charging too much for it. But what if we charged less? What if we said n was negative 1 or negative 2, negative 3? Eventually we just get to n is negative 10, and that means we are charging 0 for our sandwiches, which means our revenue is 0. We'd be giving sandwiches away. So that's the shape of the parabola. This is our vertex right here. And what this shows us is we will have a maximum revenue of $4,500 when we increase the price by 5. So we go back to our cost, and we know that's 10 plus 1n, but now n is 5, so that is 10 plus 1 times 5 is 5, which is equal to $15. But we can also figure out how many we're going to sell. So the number sold is equal to 400 minus 20n, and n is 5, so that's 400 minus 20 times 5 is 100, so it equals 300. So we sell 300 sandwiches. And this is actually kind of nice. We charge more, we make more money, and we make less sandwiches. So that is how we would solve all this. We've kind of covered everything. We'll push that up. But we should state the domain. So the domain, our variable is n, such that n is an element, in this case is a natural number, but we'll write it as a real number because it could be anything. We could increase the cost by 2 cents. And we know that it has to be greater than 10, can equal 10, but it can also only go up so high. And in this case, we'd have to find our other root, which I haven't done. So it has to be less than 10. Actually, in all honesty, it can go up as high as we want. We can charge infinity if we wanted. Okay, and now the range is the revenue. such that the revenue is a real number, right? That's a funny looking R. And it has to be less than 4,500. So we know that the revenue is less than or equal to 4,500. It also, R has to be greater than or equal to 0. Unless you want to give money away. But I think in this case, it's reasonable to assume that we are going to make $0 if we charge, or just charge too much, or if we charge too little. And that's everything you need to know for this problem.